In this video, we are going to discuss about Boolean algebra. Here, you will be learning about Boolean algebra, then fundamental concept and basic laws of Boolean algebra, and Boolean function and minimization. This Boolean algebra is developed by George Boole, an English mathematician. And this Boolean algebra has only two values, zeros and ones. And it has only three operators: logical addition, logical multiplication and complementation. Logical addition will be usually represented as OR operator, and logical multiplication as ON AND operator, and complementation as NOT operator. AND operator is logical multiplication. It will be denoted by dot, and as you see, we have only two binary variables, that is only two binary values, 0 and 1. So if I have all possible combination, then we can have it as a tabular column. So 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, and 1 into 1 is 1. And similarly, logical addition, that is OR operator, here 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is also 1. Means if any one digit, that is x or y is 1, output is 1. And we have NOT operator. NOT operator means complement. So if the input is 0, then you will be getting 1, and if the input is 1, you will be getting as 0. And we have actually 6 postulates of Boolean algebra. The first postulate is closure property. That is, set B is closed with respect to operator plus and dot, since the result of each operation is either 0 or 1. That is the closure property. Your output should also be 0 or 1. Next postulate is identity element. That is, for the plus operator, the identity element is 0. That is, x plus 0 results in x only. Similarly, for dot operator or AND operator, the identity element is 1. That is, x dot 1 is x. Third postulate is commutative law. That is, x plus y is equal to y plus x, or x dot y is equal to y dot x. We can easily prove by writing all possible combinations. That is, x and y, we know it can have only two values, 0 or 1. So these are all the four possible combinations: 0, 0, 0, 1, 1, 0 and 1, 1. So we can easily prove it. X plus y is equal to y plus x. Similarly, x dot y is equal to y dot x. Fourth postulate is distributive law. That is, x dot y plus z is equal to x dot y plus x dot z. Again, we can prove it by writing all possible combinations. Since we have three variables, x, y and z, there are 8 possible combinations, 0, 0, 0 to 1, 1, 1. So if I have this here, x dot y plus z, similarly if I multiply x dot y and x dot z, then we are adding, means x dot y plus x dot z. So this column and this column have same values, so this is proved. Another form of distributive law is x plus y dot z is x plus y dot x plus z. This is unique for Boolean algebra. It is not applicable for ordinary linear algebra. Here x plus y dot z is x plus y dot x plus z. Again, we can prove it by writing all possible combinations. So if you see here, this column x plus y dot z and this column x plus y dot x plus z, both are same. Next postulate is x plus x bar is equal to 1. Similarly, x dot x bar is equal to 0. Then sixth postulate is there exist at least two elements x and y such that x is not equal to y. So this is proved, or this is proved in this postulate, in this Boolean algebra, because we have two variables, 0 and 1, which is not equal. 0 is not equal to 1. And we have some important theorems of Boolean algebra. that is x plus x is equal to x, and x dot x is equal to x, because 0 x can have only two values, 0 and 1. 0 plus 0 is 0, 1 plus 1 is 1. Similarly, x plus 1 is equal to 1. So this is very important. When you are applying simplification, then we will be applying this law. X plus 1 is equal to 1. That is 1 plus any variable is equal to 1. Similarly, x dot 0 is equal to 0. Then another law is absorption law, that is x plus x dot y is equal to x. By duality means this plus is changed to dot and this dot is changed to plus. That's what duality. So by duality we can have x dot x plus y is equal to x. Another law is involution law, that is x double bar is equal to x. 0 when I complement it will become 1. 1 again if I take complement then it will become 0. That's what x double bar equal to x. Similarly, we can have associative law also. X plus y plus z means first I am adding y and z, that I am adding with x. That is equal to first adding x and y, and that if you add with z, that will also give you the same result. Similarly, x dot y dot z means first I am multiplying y with z, then I am multiplying with x, that is equal to x dot y dot z. First I am multiplying x and y, that I am multiplying with z. So that also will give you the same result. Another important law is De Morgan's law, that is x plus y the whole bar is x bar dot y bar. Similarly, x dot y the whole bar is x bar plus y bar. Just to remember, break the line, change the sign. So this plus should be changed to dot, and this line we have to break it. Means x plus y the whole bar is x bar dot y bar. This is another important law. It will be useful for simplification. This proof you can easily do by just substituting all possible values. Since we have 3 variables a, b, c, we can have 8 possible combination. So if you see here, a plus b plus c means b and c I am adding first, that I am adding with a. That column, and that is equal to this a plus b plus c means first I am adding a with b, that I am adding with c. Similarly, this another associative law, that is a dot b dot c is a dot b dot c. Then as I already told, this De Morgan's law is an important law which will be useful for simplification. That is x plus y the whole bar is x bar dot y bar. Break the line, change the sign. X dot y the whole bar is x bar plus y bar. That also can be proved by just substituting all possible values. Then another important principle is duality. That is, here the first row is 1 plus 1 plus 1 means that plus if I change it to dot, and this 1 if I change to 0, that also will give you the same result. So that is 1 plus 1 is equal to 1 means then 0 dot 0 equal to 0 is also valid. So if you know the first row, then second row can be just derived by using this duality principle. And this is the summary of laws, whatever we discussed so far. This we can just summarize as and law, or law, and not law, which will be useful when you are going for simplification. So this table, if you remember, that's enough. X dot 0 is equal to 0. X dot 1 is equal to x. This and all just in linear algebra also it is the same. Just multiplying by 0 will result in 0. Multiplying by 1 will result in the same value. And x dot x is equal to x because x can have only two values, 0 and 1. 0 into 0 is 0. 1 into 1 is 1. Similarly, x dot x bar is equal to 0. Or law, x plus 0 equal to x, x plus 1 equal to 1. Because x can have two values, 0 and 1. 0 plus 1 is also 1. 1 plus 1 is also 1. So x plus 1 equal to 1. and x plus x is equal to x. Again, we can have only two possible values, 0 and 1. 0 plus 0 is 0, 1 plus 1 is 1. X plus x bar is 1 and x double bar equal to 1, that is the involution law. And in addition to this AND law, OR law and NOT law, you should remember De Morgan's law and distributive law. Then only we can simplify the Boolean expressions using these laws. Just one proof let us do. X plus x dot y equal to x. So how to simplify this or how to prove this is just x you can take common outside, that is 1 plus y, that is the distributive law. Then 1 plus anything is 1, so 1 plus y is 1. Then x dot 1 is x. That's how we are getting the value as x. Then let us discuss about the Boolean functions and its minimization. In this, we will be discussing about the min term, max term and SOP as well as POC. POS means sum of products and product of sum. Let us take the example a plus b into a plus b c, that is we have to prove it as a plus bc. So that is simple because this is distributive law. So this distributive law you may not be familiar because this is applicable only for Boolean algebra. Since here a is common, a plus bc, that is a plus b, a plus c. This is actually distributive law and we can prove it also. Just ordinary distributive law which is applicable for linear algebra also, that is we are familiar, so that we can apply here. So multiply a into a into c, similarly b into a and b into c. So we will be having 4 terms. Then a into a is a, so a, then a plus ac plus ab plus bc. A if I take common outside, then it is 1 plus c, 1 plus anything is 1. So you will be getting 1, 1. So a into 1 is a. Then again I am taking a common, 1 plus b. Or you can take in the 3 terms itself, you can take a as common and 1 plus c plus b you can write. Then also it is correct. 1 plus anything is 1. So 1 plus b plus bc. So you will be getting a into 1 plus bc, that is nothing but a plus bc. Let us take another example. A plus b, y equal to a plus b, a dash plus c, b dash plus c dash. So first step, you multiply the first 2 terms a plus b into a dash plus c. That is when we have 2 terms, a plus b and 2 terms, when you multiply you will be getting 4 product terms. So a into a dash, a into c, a dash b plus b into c. Actually this dot is there, so it is implied. Then again a into a dash is 0, so remaining terms we will write and then again multiply. You will be getting ac into b dash, ac into c dash. Okay, similarly a dash b into b dash, a dash b into c dash. Similarly bc into b dash and bc into c dash. So if you take here this a b dash t c will come, here c into c dash, so that is 0. Here also b into b dash 0. This term will come and this term becomes 0 and this term becomes 0. So you will be getting only these 2 terms, that is a b dash c and a dash b c dash. Sorry, this is c dash. Next example, ABC plus ABC dash plus AB dash C plus A dash BC is equal to AB plus AC plus BC. Again, in the first 2 terms, AB is common, you take outside AB, then C plus C dash plus AB dash C plus A dash BC. Then C plus C dash is 1. If you multiply by 1, it results in the same value. So just write AB plus AB dash C plus A dash BC. Then again a can be taken outside, b plus b dash c plus a dash b c. B plus b dash c, you can use distributive law. B plus c, b plus b dash. B plus b dash is 1. So you will be getting ab plus ac plus a dash bc. Now again you use distributive law, and AB and A dash BC. In these two, B is common, you can take outside. Then A plus A dash C plus AC. Then again we have to use distributive law. A plus A dash, A plus C. A plus A dash is 1. Then you will be having B into A plus C, that is nothing but AB plus BC, and this AC is there. This is what the answer we expect, or this is what we need to prove. Next example, x plus y into x plus y dash. Just multiply x dot x, x dot y dash, yx plus y into y dash. Y into y dash is 0, x into x is just x. Then x plus xy dash plus xy. Then x can be taken common outside. Then 1 plus y dash plus y. 1 plus anything is 1. So you will be getting the answer as x. Let us take another example so that you will be familiar with the simplification. So you should be familiar with the laws as you see here. So once you be familiar with the laws, then only we can solve using these laws. So this method is called actually algebraic method. Here in first term and the third term, a dash b dash is common. I am taking common outside. So 1 plus d, remaining terms I am writing as such. One plus d is 1. So you will be getting this expression. Then you can take a dash b dash as common term here in this 2. Just I am rearranging for the convenience. Now a dash b dash if I take outside means 1 plus c d dash, 1 plus anything is 1. Then you will be getting a dash b dash plus a dash c dash d dash. Then if you want a dash, you can take outside b dash plus c dash d dash. But that is not the simplified expression, or this expression and this expression both are same. Next theorem is another important theorem, that is consensus theorem. AB plus A dash C plus BC is AB plus A dash C. To prove this, we have to multiply this BC by A plus A dash. Then only we can prove. So just I am multiplying by A plus A dash. Means A plus A dash is 1. That doesn't change the value. So when you multiply, you will be getting A dash BC plus ABC. Now, in the first term and the fourth last term, AB is common. I can take common outside. Then 1 plus C. Here in the second term and third term, A bar C is common. You take common outside. Then 1 plus B. So then you will be getting AB plus A bar C. This is another important theorem, consensus theorem. So here AB, here B and C is there, that will be removed. Okay, AB plus A bar C will be the answer. And next type of Boolean expression, or just for convenience, we are calling it as the Boolean function, we are calling it as sum of product and product of sum. That is, for example, you take this expression, f of ABC is ABC plus A dash B C dash. So if you see here, this ABC is one product term, A dash B C dash is another product term, and we are adding these two, that is the sum, plus is the sum. So this is called sum of product. And again this ABC, so this term has all the variables in the uncomplemented form. So here if you take A dash B C dash, A and C dash in the complement form and B is in the true form. Again, this A dash B C dash is also having all the three variables. If all the three variables are present, then that product term is called min term. So min term is a product term that consists of all the variables in complemented or true form. Another example is x dash y plus z, x plus y dash z, and x dot y bar plus x bar y. So this and all, as you see, these and all the product terms, but they are not the min terms. Okay. We can convert into min terms. That we'll do later. So these are the examples. A dash B dash C dash plus A dash B C dash A dash B C plus A B C. So as you see here, all the terms have all the variables. Okay. Again, so this is dash means it is 0. So this is 0, 0, 0. 0, 0, 0 means it is 0. So M0, min term 0. Then this is 0, 1, 0. So min term 2. This is 0, 1, 1. 0, 1, 1 means 3. So M3. Then 1, 1, 1 means 7. M7. So we can write like this, sigma M of, sigma as you know it is sum term. Sigma M 0, 2, 3, 7. Similarly, we can write this as well as this. Canonical form means it should contain, that Boolean function should contain all the variables in each term, each product term. For example, here f of ABC is AB plus BC plus AC. So as we know, this function has three variables A, B, C, but each product term is having only two variables. So in the first term, C is missing, in the second term A is missing, and the third term B is missing. So for that, what we have to do is, we have to multiply by the missing terms. Okay. And C plus C dash, just if I multiply by C plus C dash, it is not going to change the value because C plus C dash is 1. 1 into anything will give you the same value. So it is not going to change the value. That is more important. So BC, A plus A dash, AC, B is missing, B plus B dash. Just you multiply with the missing literals and their complements. Variable, another name is literal. That's it. Now you expand ABC, ABC dash, ABC, A dash BC, like that. Just multiply and just remove the redundant terms. Here ABC is coming 3 times, so only 1 time if you write, that's enough. Okay, so just write once ABC and remaining terms you write ABC dash plus A dash BC plus AB dash C. This is how we have to convert the standard SOP into the canonical SOP. Next type of Boolean expression is product of sum. Here, just you take this example, f of ABC is A dash plus C, A dash plus B plus C dash. So here, this is a one sum term and this is another sum term, and we are multiplying both, or we are taking product. So this type of expressions, we call it as product of sum. So here, as you see again, A dash plus B plus C dash. Here, all the three variables are present. If we have all the three variables in a sum term, that we call it as max term. And as we see, max term is the complement of min term. These are another few examples for product of sum. X plus y dash, x bar plus y, x bar plus y bar. That is, this is one sum term, this is one sum term, this is one sum term. Just multiplying all the three. We are taking dot. Okay, so this. But as you see, these are not canonical form. So here, if I take the first term x, y, only two variables are there. All the three terms consist of all the variables, all the two variables. So then it is a max term, and it is a canonical form. And here if I take x bar plus y plus z, here this is a max term and this is x plus y. This is not the max term. So here if I take f of x comma y, only two variables, and these two terms consist of all the variables. So then this is one max term. X bar plus y is one max term. X plus y bar is one max term. And this expression, Boolean function, is in the canonical form. So in terms of max terms, if I want to write the expressions, then just to take this example, here we have to consider without complement or the true form as 0. So if I write a plus b plus c, it is actually 0, 0, 0. So 0, 0, 0 is 0. Similarly here, this is 0, b dash means I have to just mention as 1. So 0, 1, 0, that is nothing but 2. So here it is 0, 1, 1, so it is 3. Here 1, 1, 1, so it is 7. So 0, 2, 3, 7. This pi represents it is a product or multiplication. And this capital M represents max term. And let us see how to convert the standard POS into the canonical POS. And I am taking a specific example. This is a plus b, b plus c and a plus c. This is standard POS. But here this c is missing. Here a is missing. Here b is missing. So we have to add these terms. Okay, for that what we have to do is a plus b plus c dot c dash. C dot c dash means it is 0. When you add 0, then it is not going to change the value. So I am adding like that. Similarly, b plus c, a is missing. So multiply a and a dash and that you add here. So similarly, b dot b dash we have to add with this term. Then expand. Here, by using the distributive law, a plus b plus c dot c dash is a plus b plus c, this term, then a plus b plus c dash. Similarly here, b plus c plus a dot a dash is a plus b plus c, a dash plus b plus c. We have to be careful in writing the variables in the order of ABC. Then only we can write the max terms properly. Similarly here, a plus b plus c, then a plus b dash plus c. Again here we have a plus b plus c 3 times. So just write one time only. Remaining terms we can write. This is what the max terms. Each is the max term. If in the Boolean function, if all are max terms, then that kind of expression we call it as canonical form. Similarly, SOP also, if all are min terms, then it is canonical form. And another thing is conversion between canonical forms, means sum of product and product of sum. That is very simple. For example, fxyz, if I have pi, that is the max terms, 0, 2, 4, 5 means, then if I want the SOP form, then the remaining terms, whichever is not there, that we have to write. So sigma of 1, 3, 6, 7. So totally for 3 variables, we will be having 8 possible combinations, 0 to 7. So here 0, 2, 4, 5 are there, remaining we have to write. Similarly here if I have 1, 4, 7, then remaining terms between 0 to 7, the missing terms 0, 2, 3, 5, 6 we have to write. So this is SOP and this is POS. And this is the summary of min terms and max terms for 3 variables just for convenience. Here 0, 0, 0 means we have to write the min term as x bar dot y bar dot z bar. That is M0, that is a small letter or the lower case M0. Okay, for the max term for 0, 0, 0 means it is x plus y plus z without complement. Then this is capital M0. Similarly 0, 0, 0 means in the min term we have to write with bar or the complement. in terms of max term, we should not write the complement for 0. Okay, so 0, 0, 1 means here x bar dot y bar dot z, whereas in the max term, we will be writing as x plus y plus z bar. So as you see, min term is the complement of max term or vice versa. Thank you for patient listening.